Okay, so now let's talk about how to prove trig identities. So, using the trig properties that I showed in the last video, it should be pretty easy to prove these trig identities. You just have to know which trig property to use. So, in this example, show that sine of x times cotangent of x yields cosine of x. Now, the first step that I'd recommend to any trig identity proving problem is to convert everything into sine of x or cosine of x. This just makes it easier because you can go from the hard ones like cotangent of x to the easier ones that are very common in these problems like sine of x and cosine of x. And you can also tell that you should do this because you don't see a cotangent of x on this side, so you just have to change this. It just works that way. And the second piece of advice I would give you is that always start with this side. Just kind of don't worry about this side. Just make this side try to look like this side, but don't change anything on this side unless absolutely necessary. So first, let's start off with this. Sine of x times cotangent of x. Right here, I'm already seeing something very obvious that we could do. We could change cotangent of x into cosine of x over sine of x, right? That's one of the properties. I think that's the reciprocal property, I'm not very sure. The names aren't that important. Over cosine of x, right? So now you'll see that these two can cancel out. So you end up getting cosine of x. So boom, you got it. You got this, what it should yield. So now let's go on to something a little bit harder. Show that cosine squared x minus sine squared x yields 1 minus 2 sine squared x. Okay, so here what I'm seeing is cosine squared x and sine squared x. I know that there's a property that involves cosine squared x and sine squared of x. Right? That property is cosine squared x plus sine squared x equals 1. That's, what do they call that property? Hold on a second. That's called the Pythagorean Property. Duh, why didn't I know that? So, because everything on this side is only in terms of sine, we should use this and convert it so that it only has sine in it. So, the way to do this is that we can solve for cosine squared x using terms of sine, right? So, cosine squared x equals, let's subtract sine squared x to both sides, from both sides. So we end up getting cosine squared x equals 1 minus sine squared x. So now we can substitute this here, cosine squared x, with 1 minus sine squared x minus sine squared x. Okay, right? So now you should notice that this should be 1 minus 2 sine squared x, which is exactly what we were trying to show that this could become, right? Now let's do some harder problems. So now let's do a problem that's a little bit harder. I like this problem because it uses a lot of the properties that we learned in the last video. Okay, so let's start it off. Show that cotangent of a, and I should note here that in this problem it uses a, in the last couple of problems it used x. This variable, it could literally be any letter. Here it's a, it could be b, it doesn't matter. Anyway, show cotangent of a plus tangent of a yields cosecant of a times secant of a. So, the first step of any proof for trig identities is always try to write everything in terms of sine or cosine. It just works better that way because the properties, most of them use sine and cosine, and it's just easier when everything is terms of sine and cosine, right? Okay, so here we see cotangent of a. We can rewrite cotangent of a as cosine of a over sine of a. And then we have tangent of a. So tangent of a should be these two reversed. So sine of a over cosine of a. Okay? So now this next step might stump a couple of people because you're just like, what do I do? This doesn't work. But really, whenever you're stumped and you have an addition sign, you should always try to have a common denominator. And that can be achieved by multiplying this side by whatever this denominator has that this denominator doesn't have. In this case, this denominator has cosine A, and this denominator only has sine of A. So we have to multiply it by cosine of A. And we have to multiply this side by sine of A over sine of A, because this denominator does not have sine of A. And I should note that you can't just multiply the denominator by something, you must multiply the numerator by that same thing too. Okay, so now we end up getting cosine A squared, cosine A times cosine A, and sine of A squared. Over, now that the denominators are the same, we can add these two together. So it's going to be cosine A times sine of A. Now this top part looks a lot like a Pythagorean theorem, Pythagorean property that we all know, right? Cosine squared A plus sine squared A should equal 1. Now the denominator is going to stay the same. Now we're almost there. But you see, we have cosecant of A and secant of A, and here we have this. Now, what we can do here, this is totally achievable, we can just break these two apart. It's the same thing, because this 1 can be distributed, right? 1 over cosine of A times 1 over sine of A is the same thing as this, right? It's just broken apart. You can do that. Now, we can rewrite these as cosecant A and secant A. Or we can write, whoopsie, they're in different orders, but it's the same thing. This is going to be secant A, and this is going to be cosecant A, right? So here, you get this. It's just in different orders. It shouldn't matter if it's in different orders. I could have rewritten this as 1 over sine of A times 1 over cosine A, and then I would get cosecant A times secant A. The order doesn't matter. It's just important that you got the same thing. And we did. So, yay.